after spring break. You still following me in this adventure? Okay, so the Monday after spring break, if you owe me any homework assignments, you can turn whatever you need in. I'm not assigning you homework over spring break, so don't take this as, oh, Storp's giving us homework. No, you didn't turn your homework in, therefore you can make it up. Whatever's not turned in stays as the 0 in the grade book. And then once we start teaching on the Monday after spring break, and then keeps going with the new unit, if you have your homework that day, you get a 4. If you're not here, we put an absent. You turn that in within the following day or two, you'll get the full 4 points. If you turn an assignment late and you weren't absent, you're going to get a 3. That's the highest grade you can get on it. Okay? And we're doing that for a couple reasons. One, we want you to be prepared for next year's courses, but also sometimes your parents are looking at the grades and they don't understand how weighted grading takes place because they haven't been in high school for some time. Hey, and then so you can take care of that. So you have 2 of them. Do you wanna chill in here? I'd say like somewhere in that back row over there, or you can even sit at the front table if you want to sit with the freshies. Use what you need, okay? Giddy up. All right. So, so that's what we got. Are we good so far? We're happy, set, content. Okay. Let me just take attendance real quick. Okay, I'll go over there. Was Morgan here? Okay. Just making sure. All right. I'm coming out to you. Did you find it? Yeah. All right, my friends. I am going to be on page 105, 105. We good? All right. Where can I sit?
Where now the frogs go?
Hey, I'll sit at the middle table, fiddle in the middle. All right. So there's one last form that parabolas are put in. And I think you actually will appreciate this form. And I'm actually going to show you on Desmos basically what's taking place with the problems. So page 105. A couple things that this is at the very top. This still deals with the A times 135 pattern graph. This shifts left if positive, right if negative. And I'm going to explain what all this means in a minute. And if I add this, so this is like the very top thing. This shifts up when it's positive, down when it's negative. Now, these are called vertex form for a reason, because it indicates the vertex. So the vertex in this situation, just using letters, will be H, comma, K. This is always the opposite sign. And this is always the same sign. Okay? Now, I know I haven't really gone over an example. I'm just kind of putting some extra little notes if you want to squeeze them in. So that whatever's out in front of the parentheses is the A value. That goes along with the A times 135, that pattern graph. The H value is the X component of the vertex. If we added H, it shifts left. If we subtracted H, it shifts right. And then the K value, which could be a number, is outside the parentheses. That shifts the graph up or it shifts it down, okay? And then the vertex is at HK. So the vertex is handed to you with the problems. Next book. We're on page 105.
Okay, thank you.
Yes. All right. Can I move off the screen? Okay, I think you're going to appreciate this. I'm going to jump into something called Desmos. And what I'm going to do is, you don't have to really write these graphs down yet, because I'm going to come back. I will come back and actually draw them on your graph for you. Just pay attention. So this is called the parent function. Okay, it's the most basic parabola there is. This parabola has a vertex at 0, 0. And if we pattern graph, I go right one, up 3, right one, up 5, or left one, up 1, left one, up 3, left one, up 5. That all takes place. Okay, so this is our most basic parabola. So let me change colors on it, and I'm going to do this one. I'm going to go y equals x squared plus 3. So here's my vertex of this one. Here's my vertex of this one. So tell me in your own words, what did it do? Yeah, I just moved up. I went from the red to the blue. I moved up 3. Why did I move up 3? Because I added 3. The 3 was not inside of parentheses. I added 3, and it just moved the whole thing up. So what do you think y equals x squared minus 2? What do you think letter C is going to do?
It's going to go down 2.
Yeah, it's going to go down 2. X squared. And then if I go minus 2. So again, take note that the red is our original. And I can click on the vertex of each. So the blue one, when I added 3, the whole thing shifted up 3 from 0, 0 to give us a vertex of 0, 3. The green one shifted down 2 because I subtracted 2 from the x squared component. It's not grouped together. Okay? So that's visually what's taking place. Each of those will indeed grow as 1, 3, 5 from the vertex. Okay, and we've worked on that. So let's take this back to this front page. So this had a vertex at 0, 0, grows at 1, 3, 5. This has a vertex of 0, 3, grows at 1, 3, 5. This one has a vertex of 0, negative 2, grows at 1, 3, 5. Okay, so let me do this one in red. 0, 0 is right here. Then I go right one, up 1, right one, or left one, up 1, right one, up 1, 2, 3, left one, up 3, so on and so forth. So that's basically the most basic parabola that you have. Good? If I do the next one, let's pick some fun colors. Stirrups going to the pink. If I do this one, 0, 3 is right here. Pattern graph's the same way. Right one, up 1, left one, up 1, right one, up 3, left one, up 3. So this one was up 3. Okay, and again, I know I did it on Desmos, but I wanted to show you how, things I'm not finding. Negative b over 2a plug a negative b over 2a back into the equation to get the y value. I'm not finding roots necessarily. I'm just pattern graphing and finding the vertex. The vertex handed to us, and we're just going from there. And then we'll do this one in green. So 0, -2 is down here. Right one up one, left one up one, right one up 3, left one up 3. And that's what they look like. Okay? Domain of all these is negative to positive infinity. The range is based on the y value of the vertex. I think I have kind of pretty colors up there. Of course, the colors I'm seeing might not be the same colors y'all see because this dude's pretty partially colorblind. I see brown and gray as the same color. And I kid you not, we have a couch in our family room that I felt clashed with the chairs. My wife's like, no, it's a gray couch. I'm like, no, it's brown. And my wife's like, okay, this is a brown shirt. They're like, yep, same color. This is a gray shirt, same color. It's really kind of weird.
That looks brown right now. The chair. Or his. Does my backpack look gray?
It's brown.
I mean, that's what I meant.
Is it gray normally?
Yeah.
I mean, the North Face part is black, and the straps are black, and the jester at the bottom is black. But it's a black on brown backpack. That's what I see. Isn't that kind of crazy?
Only gray and brown.
What's that? So, I don't know yet. There are definitely times I'll come downstairs wearing something. My wife like, you wearing that? No, I'm just trying something. So, yeah, it's kind of weird. I had no idea I had it until probably about 8 or 9 years ago. Then I went to the eye doctor, and I go every year, and he's like starts doing the colorblind. So it is the brown gray that I can't see, which is crazy. They just all look the same. I believe this table, this looks like it's brown to me with darker brown highlights, but y'all could mess with me saying, no, this table's gray.
No, it's brown.
Okay. Okay. All right. So I should never teach at a high school that doesn't have colors that I can't see. Yeah, we're brown and gray. That's like the ugliest colors. And I'd be like going, it doesn't matter to me. I imagine some high schools brown and gray. Ugh, yuck. That would be bad. All right. So let me look at these next two problems. So this is halfway down on page 105. And I'm going to jump back to Desmos. And I'm going to get rid of my original two. So again, I have my most basic parabola up there, 0, 0, vertex. Pattern graph, right one up 3, left one up 1, left one up 3. Agree? Okay. So now I am going to not have the 3 outside of the parenthesis, I'm not going to have the 3 outside the parentheses. So the red is at 0, 0. Take a look at where this vertex is. So I went from 0, 0 to -3, 0. Now, this is the one that's really unique to look at. And I get it. In your mind, you want it to work a certain way. Trust me, I want to be able to see the difference between brown and gray. Okay? But I can't. So take a look. It is grouped. It's x plus 3. Doesn't your brain want to say that it should move right? But it shifts left. And the reason it shifts left is if I take x plus 3 and set it equal to 0, I have to subtract 3. That's basically why it shifts. So whatever I plug it in, whatever is in parentheses, if it's added, it shifts left. If it's subtracted, it shifts right. So let's look at the bottom one. It says y equals quantity x minus 2. Okay, so notice what took place here. This one's black. This is my original. So it's a subtracted 2 that is grouped. It's in parentheses. It shifts to the right. Okay, You see how that kind of works? So the vertex of the first one, 0, 0. The vertex of the second one, negative 3, 0. Vertex of the third one, positive 2, 0. Agree? All right.
Also, because the signs are different.
The opposite signs. If something's grouped in math, when it comes out, it shifts right or left, and it's always opposite of what your mind would want to think. It's one of the mean tricks they played on us back in the day. All right, so vertex of the first one, 0, 0. Right one up 1, left one up 1, right one up 3, left one up 3. Parabola there. That's my original function. Okay. So this one is negative 3, 0. So this one, oh shoot, I forgot. Looked like I put. Oh jeez. Did anyone else see that error, or was it just me? Okay. Yes, FT left 3. Okay, sorry about that. So right one up 1, left one up 1, right one up 3, left one up 3. So that's what takes place with that. Well, actually, I taught this in the beginning. Y'all would have been like, "Yeehaw, I'm on it." And then the last one, 2, 0. Let's not make the error again. Okay. Right one up 1, left one up 1, right one up 1, 2, 3, left one up 1, 2, 3. That's what they all do. They shift right, left, up, down. Seem okay so far? Can I go off the screen, or are you still copying? Almost done?
People have brown hair that it just looks gray to you.
You mean you're not gray? I didn't want to say anything. I thought you were just one of the early grayers.
Wait, so my hair looks gray to you?
Yeah, I'm getting grayish tones in there.
Oh, wow.
Yours looks black to me. I would say you have black hair, but I might be totally wrong. Dark brown is probably the true color. What did I do?
I have no idea yet. I hear you. Do you like see like your hair look brown?
I got a lack of hair. It was all the anxiety, not me not being able to tell the difference between the two, and then all of a sudden, oh, it's just falling out. The gray parts in it, they look brown. I'm kidding. I used to have beautiful hair, and all of a sudden, I don't know my hair when I was in high school was like white. It was bleach blonde.
Oh, wow.
Well, I worked outside, so the sun bleached it all the time. Because I was a salesman for a car wash and lube and oil and detail shop.
Oh, wow.
And so I used to I had the whitest hair. It was wavy. It was beautiful. Yeah, it happens. It's one of life's jokes. I laugh at it. It had no big, my buddies will go back home. They're like, "Dude, sure, if you're bald." I'm like, "Yeah, but y'all are fat." I'm like, it's kind of the fun. They're like, "Yeah, but we can lose weight." And I'm like, "Prove it."
And then next thing you know, they're eating the cookies.
All right. Last example. So notice, my friends, these next ones on page 106, I believe it is. There's my parent function. But now I'm just going to change my leading coefficient. Oh, let's change colors.
Yeah, I'll do it now.
Okay, so notice the vertex stayed the same, yes? This made it skinnier. I multiplied by a number larger than 1 out in front, and it made the parabola skinnier. Now I want to show you something. Okay? This one is not on your paper. Okay? I'm going to put a really small fraction, meaning a small fraction means I have a really large denominator. So 1/30th is a really small fraction. Look at how fat it made that parabola. Okay?
Just like your
So the 3 out in front on the green one is called a vertical stretch. The 1/30th in front, I know it's not on there, is actually called a vertical compression. So it flattens it out, it widens it out. So that's kind of cool. I know you don't have that example on there, but I just wanted to show you that takes place. Good to see you, buddy. So the -2 x squared. Notice the negative makes it skinnier than the red, and it also flips it upside down. Okay, so those are a couple things that take place with those. All right, so all of these have a vertex of 0, 0. They're all 0, 0. So 0, 0 is favorite point right now. Let's do this one in blue. Right one up 1, left one up 1, right one up 3, left one up 3. Do this one in green. My pattern graph on this one's not going to be 1, 3, 5. 1, 3, 5 is on top, so I'm going to go 3, 9, 15. So right one up 3, left one up 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Jeez, it's up here somewhere. You get all done?
Yep.
Appreciate you.
Thank you.
And then this one, the pattern graph is going to be -2, -6, -10. So from our vertex, down 1, or excuse me, down 2, I apologize. Down 2, down 2, down 6, 1, 2, 3, 4, 5, 6, down 6. All right. So that's the long and the short of everything we're doing. Okay. So the A value tells you which direction it's going to open, up or down. It's going to tell you how fast or how slow your pattern graph is going to do. Okay. How fast or slow it's going to grow. Okay. So let's take a look at this. So let's take a look at this very top one. Friends, what do you think the vertex should be on this top one? What do you think? How much? Hey, Morgan. I'll take that. And take the earbud out, please. Don't throw it to me. I can't catch. I was a lineman. Here, just put it right here on this desk right here, please. Deal? Don't. Love this game. Hey, what's my vertex? What's my vertex?
-2, -5.
Close.
-4.
What happens when it's inside? What?
Positive 2, 5.
2, -5, right? So 2, 5, -5. 1, 2, 3, 4, 5. Is the pattern graph going to be 1, 3, 5?
Yeah.
Yep. So right one up 1, left one up 1, right one up 3, left one up 3, so on and so forth. All right, let's do this one in blue. Let's get the vertex first. What's the vertex of the blue one? How much? I heard it. I thought I heard it. Start sharing things. It's those voices in my head. Voices are scaring my hair away. Vertex, what do you think? close. -6 is totally right, and +9. So it's always opposite when it's grouped when it comes out. Always the same when it's not grouped. So, so -6. 1, 2, 3, 4, 5, 6. +9. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right. Pattern graph. What am I going to multiply times 135? -3. So this one's going to open down, yes? All right. So I'm going to go right one down 3. Left one down 3. Right one down 9. And left one down 9. All right. Okay, that's it. That's all we got. So why don't we give you page 107, 1 through 6. I'm giving you a good amount of time to work on this. You know what gets frustrating is when we go to check it off tomorrow and being you had like 15 minutes, 18 minutes to start this. You're like, I don't have anything. Good, you wasted my time. You show up tomorrow and you were here today and you show me absolutely nothing that you did for the next 18 minutes. That means you owe me 18 minutes in your dean's office. Deal? Deal.